Thanks, Ian, for helping us out architecturally with our beautiful building built 60 years ago. Can you tell us some of the unique features regarding this building architecturally?
Yes, indeed. Well, when the building was first designed, it was intended to reflect the rugged environment of the northwest, and the building with its concrete was expected to show the rugged northwest. And the star-shaped plan was intended to show that the gospel was to spread to all directions of the compass.
Beautiful. So as a design, it's quite incredible. Tell us about a little bit about the construction technique or engineering techniques that have been used to hold the building together.
Yes, well, it was an in situ concrete building, which means that formwork was put up and the formwork was filled with concrete. And it means that there are some errors in the way that reinforcing is installed in it, and as they pour concrete in, there are pressures that move the reinforcing around. All those separate panels between the windows are tied together with this concrete ring beam, which supports the top of the walls and also the steel roof framing underneath the roof. So one of the problems associated with the in situ concrete is that because of its imperfections and the fact that we're close to a marine environment, the coastline, with wind-driven salt air, that salt air can penetrate the concrete and the salty moisture is absorbed into it and can rust the concrete where it's not protected sufficiently.
Yeah, so that's some of what we've been experiencing at the moment, and in my understanding we've got three key issues with this building at the moment. Can you run through those three key things?
Yes, well, for a long time we've known that the roof has been a problem. It's an asbestos roof.
So this is all corrugated asbestos.
Correct, yeah. And access to it is difficult, and when you walk on it now it's brittle and it's cracked and the cappings are rusting. We've done some temporary works on it which made it temporarily waterproof, but really in the long term it needs to be replaced.
So is that normal for an asbestos roof after 60 years?
Yes, indeed. Many people would know that the asbestos roof at Bluff Point Hall has recently been replaced for that very reason.
Okay, all right. So that's the first problem, obviously water leakage in through this breaking down roof line. What's the second issue that we've observed?
Well, the second issue is the apparent breakdown of the concrete inside the building, for one thing. Recent work has shown where it's breaking down along the top of the ring beam. And in the past there's been some that's fallen without anyone tackling it. So it really needs to be repaired. And on the outside we know that the concrete columns are failing.
Okay, so that's issue 2 and 3. This ring beam here, and then the columns in between each section has shown signs of concrete, what they call concrete cancer.
Yeah. Just one other thing about that ring beam and the rust around the reinforcing is that those gutters which are built in behind the ring beam,
so in here somewhere, right?
Yeah, in between the edge of the ring beam and the roof, are made of short lengths of copper originally, and they're joined together with pot rivets and solder, and time and expansion has caused them to break down, and that could be one reason why water's getting into the top of the beam.
So we can see evidence of where this has concrete cancer because concrete has exploded off because the reinforcing inside this beam has rusted and therefore expanded. What's the risk there? Why can't we just, can we just slap some concrete on that and fix that? Or if we didn't do anything, what would be the potential risk?
Well, the long term is that the roof could collapse. I don't know how long that would take. All the load of the roof is taken on that ring beam and the load transferred down to the walls. So with any roof, the effect on a wall is that if a roof's pitched, it's going to flatten out. Okay. In our case, the roof is not pitched steeply, but the forces are still the same.
Right.
So that ring beam is tying all the wall panels together.
Okay. So the pressure of the roof wants to push those walls outwards.
Correct.
But the ring beam is holding it all in together.
Yeah.
So Lord, may this never be the case, but at the worst case scenario, we break that strap somewhere or other, and the whole building then becomes obviously very, very
Yeah, it
dangerous.
has a weakness in it, yeah, which could break.
Okay. So, Daryl, what are we trying to achieve up here?
So what we're doing is just identifying all the loose concrete. So where we've got the concrete cancer, where the reinforcing, the reo bars are rusting behind, as they expand, they cause the cancer to cause the concrete to crack. So we're just identifying any loose concrete and getting it down in a controlled manner, so it doesn't come down unexpectedly.
So how much force should it take to cause concrete like that? You're just using a lightweight hammer at the moment. How much force would it normally take to take concrete down like that?
Sledgehammer, jackhammer, probably more jackhammer. Yeah.
Yeah. So just using a carpenter's hammer shouldn't cause that to fall down.
Should not cause that to fall down. Absolutely.
Okay. Beck, thanks for doing this for us. We're on the outside of the cathedral here at the moment on the north side. We can see some damage that's occurred to one of the columns. Can you explain to us from as a building consultant what we're seeing here, what's actually happened to the building?
So it's commonly known as concrete cancer. So the reinforcement has reacted with water and with oxygen and has rusted out. And as it's rusted out, it expands. You can see the width of the column there is wider than here. And it pushes the very brittle concrete out, and so it bursts out.
So what's caused this particular issue to occur? Tell us a bit about the construction method and what's happened.
So for its day, this was pretty radical construction. So all the concrete was poured in situ. So they would have put big formwork up and then poured down into it. And as they pour the concrete around the reinforcement that's in there, they've got to get in there and agitate it so all the bubbles come up and out, so that you get a nice smooth surface and so you don't have air bubbles trapped. But as they're poured, and when you've got big sheets that they're pouring and probably complex joins, there might have been areas where they didn't quite get it right, and so you end up with this honeycombing. You can see that part of the concrete looks quite porous, looks a bit like pumice. Yeah, so you've got little hollows in there. So, I mean, you can see like those ones. So water can sort of work its way through and oxygen works its way through and it gets back to the reinforcement, which may not have had enough cover on it. So you need at least 50 mil of cover of concrete over the top of steel reinforcement to protect it from doing this.
So what's the solution? What will a repair look like? What will the builder need to do?
They will need to identify all the areas where it's happening. This one's really obvious because it's already happened. We can see other areas where we've got lots of crazing on our render, so something might be going on behind there, or you can see some cracking happening. So they'll remove all the loose concrete and then they'll actually remove the rusted out reinforcement and to a good margin and replace that reinforcement so that we've got the structural strength, and then they put it all back together, cover that in concrete and replace the render.
So what's the worst case scenario if this isn't repaired?
We don't know the extent, so all we can see at this point is what we can see from the outside and what we can see that's cracking. So it could be superficial, so it could be, so you know, in the case of a whole building having one part of one column fail, it's a structural failure, won't be catastrophic. It won't result in the whole building being structurally unsound. But if it is more widespread than we can see, then that could mean that our building is structurally unsound. If left unchecked, it'll just keep going. So you can see there's a crack down here now, so it just means water is now getting into the reinforcement down here.
So how can you possibly quote on something like this that needs to be repaired? Is it possible to have a definitive cost?
No. So I'll be really honest, for a building of its age and the time at which this rather radical construction method for its time was done, our building's in great condition. So we should expect to have some concrete cancer. We know that the other building that was built in the same methodology by the same builder in town at the same time is no longer here because the concrete cancer was so big they had to actually demolish the building. So we are very blessed to have a building that's actually pretty solid. Whoever's going to do the repairs can make an estimate. You can do what we've done inside, which is tap out some of the, you can test it. We can drill some core samples to see if we can figure out the extent, and they can do a quotation based on that or an estimate. But we've got to expect that it could be twice the amount of damage than what they can actually see or find.
Run us through basically how we would repair this. It's a multi-stage process, but as a builder comes in, what will they be wanting to do, in short, in order to repair the issues that we've got?
Yes, well, there are two main elements. The first one is replacing the roof, and the second is repairing the concrete. So suppose we just go with the concrete for one thing. The building will have to be scaffolded, and they'll need to test areas of wall where there's suspected corrosion, and they'll need to hack off the damaged concrete, replace any damaged reinforcing if it's needed, and the remaining reinforcing they'll have to treat for rust, protect it, re-concrete it, and put new decorative render on the outside where it's required.
And as we've explored and seen, internally we can see where this ring beam inside from underneath has started to degrade significantly. So obviously we cannot be occupying the building while the building works is taking place inside there.
No, well, it depends to some extent on the program the builder adopts, but I suspect we'd need to be vacating the building.
Right.
If the roof and the concrete were to be tackled at the same time, we estimated a 14-week period of time.
Okay. Given that with concrete cancer, we can't tell how much there is until they actually start digging into it.
Correct.
Yeah, so we
A
can't
bit
tell.
of an unknown quantity.
Can we? And therefore, not only can we not tell the timeline, but we also can't actually tell the cost at this stage,
it's
can
a
we?
bit flexible.
It is a bit flexible, which is a little bit scary, isn't it?
Yeah.
Okay. And replacing the roof then, what's involved with that? Is that an easier or a harder thing to do?
Well, the contractor appointed would employ specialists to remove the asbestos. It has to be wrapped and taken away. And again, while the building is scaffolded, they'd be replacing the existing roof with a Colorbond steel roof, which is designed to be in proximity to a maritime environment.
Right.
So it lasts longer than standard Colorbond.
Right. So you mentioned the scaffolding there. If we were to do it in 2 stages, we'd need to do the scaffolding for the concrete, and then it would be removed until such time as we could then do the roof, where we'd have to bring the scaffolding back. How much cost would we have to add doing that scaffolding twice? Is scaffolding expensive?
I think the scaffolding for the whole job was in the order of $15,000 to $20,000.
Okay.
So, you know,
We're having to add that on.
we're having to add it on, yeah.
Okay, all right. Good. Thanks, Ian. I appreciate that. Tell us a little bit about heritage listing and how that works for us.
Well, this building was subject of a conservation plan prepared by local architects and approved by the Heritage Council of WA. And that goes through a rigorous assessment by the Heritage Council. And they apply rules by which we have to look at future development around the site. And the building itself, not only the building but its fittings and furniture is part of the heritage listing.
Even these light fittings?
The light fittings are included, yep.
Okay. So, could we demolish the building? Would we be allowed to do that?
I can't imagine under the current heritage assessment that would be allowed, no.
So whose responsibility is it? I mean, Heritage has put this caveat on it. Is it their responsibility to maintain the building?
Unfortunately, no, but Heritage Council does provide funding to some extent.
Okay.
Not as much as there used to be, but we currently have a heritage grant towards the cost of this work here.
So at this stage, we're estimating $750,000-ish, realising we don't know the full extent of the concrete damage.
Yeah.
What sort of grant have we already received?
Well, it's
Heritage.
in the order of $42,000.
Okay, all right, so we're very grateful for it, but it's not going to cover the bill, is it?
No.
Okay, all right, so we have the responsibility as a diocese, as trustees, to ensure that this building, particularly as a heritage building, and the most significant building in all of the diocese, continues to be maintained, and that's a heavy load financially and maintenance-wise, so yeah. All right, Ian, thank you for all the work you've done here, and I've just been looking through some of the documentation for tender, and it's a hefty document when it comes to the work that we're expecting a builder to do, and we're prayerful, one, that we've got the money to do it, and two, that we'll find a suitable builder who's able to tackle this work and complete it. So,
That's our prayer too.
yeah, all right. Thanks so much, Ian, I appreciate that.
Okay.
Yeah.